Hello, good afternoon, everyone. Thank you for being here. Welcome to the EMS webinar. I am Maria Grazia De Angelis, and I am hosting this webinar with the help of Professor Marco Stoller from the University of Roma. And today we have a very interesting talk by Piotr BRUZDA from PCI Membranes. So it's a contribution from a private company. And the title of today's webinar is Don't Block Your Process with Membranes, Sharing Best Practices of Usage of Commercial Membrane Products. I will just say a few words about the speaker. Piotr is a highly qualified specialist in the field of membrane filtration technologies, with a particular focus on drinking water systems, submerged plus side stream membrane bioreactors, and processes for obtaining high quality products in the fine chemicals, dye, ink, pharmaceuticals, and food and beverages industry. He has a deep engineering background and is especially focused on solving technical problems. He first graduated in environmental engineering from the University of Gdansk, and then he worked for Alfa Laval, GE Water, and now he is Director of Business Development at PCI Membranes. So I'm sure you will enjoy his presentation because he is a very experienced person in the field of water and wastewater treatment with membranes. So please, Piotr, now the stage is yours.
Good, thank you very much, Maria Grazia. It is an honor to be here. Thank you for the invitation, and I'm really glad to take a part of this webinar. So let me start a few words about myself. Yes, I know that you introduced myself, Grazia. Thank you for that. But I'm Director of Business Development, so at PCI Membranes, and I'm responsible for sales, growth of business, but also for supporting technical supporting of my clients. I'm with PCI Membranes already 6 years, and today I would like to present you how you can see a different way of approaching of membranes, so you can improve your process. So what can be done in proper way to make sure that the application is successful. And I would like to present to you some few slides I did for today. Let me just only start the presentation. So you should see right now in presentation mode the slides. So let me start with the few words about agenda. So today I will introduce about filtration group and PCI membranes. After that, I will go through the role of the membranes. After that, understanding membrane. Next will be PCI product portfolio, and the last but not least, case study. So first, a few words about filtration group. So this is a very innovation company, and as a filtration group, we purified the air we breathe, filter the water we drink, make our hospitals safer, reduce carbon emissions, and enhance the effectiveness of medical devices. As you can see, filtration group is $1.6 billion revenue business with 7,000 plus employees and globally present around the globe. We, as a PCI Membranes, are a small part of this group, but as you can see over here, we are based in 2 locations, in United Kingdom in Whiteley, and manufacturing in Poznań area in Poland. We have 50 years experience, and our name PCI is coming from the two gentlemen, Patterson and Candy. So this is why we have our name Patterson Candy International, and short version is PCI. We are producer of polymeric cross-flow membranes. So our main focus is Europe, but we have also present in Americas and also both Americas in Asia and Pacific. So let me move to another slide. Now I will give you a quick introduction about the role of membranes, how PCI is seeing this. So first of all, I will start with a table, which you can see over here that this is technology available for treatment processes. So we have active carbon, chemical oxidation, UV lamp, live softening, and so on. Also ultrafiltration, cartridge filters, reverse osmosis, and evaporation. So there are technologies available on the market. So some of them, they are very good and they do the job. But if you have contamination, which is required to remove salt, there is limited right now only to osmosis processes or evaporation. Of course, you can use ion exchangers, but there are some limitations. With the suspended solids, we can do very easy with clarifiers, with multimedia filters. But if you would like to do fine clarification, then you need to use ultrafiltration. So this table is showing you that even if we have available technology, it needs to be dedicated for a specific problem, for specific stream, for specific water or wastewater application.
Excuse me, Piotr. Excuse me if I interrupt you. We are still seeing the first slide.
Okay, let me check why.
And the viewing is not in full screen mode.
Okay, let me stop. My apologies.
Okay, no problem.
Stop presenting. So now it should be better. Now you should see my whole screen.
Yes, correct. Okay, good, thank you.
So my apologies for that.
No problem.
So that was about filtration group. The PCI membrane slide showing 2 locations, and we are a leader of custom-built cross-flow membrane filtration. So we deserve to be a part of filtration group because we are making the world healthier, healthier and more productive. So role of the membrane, I've showed the table, and now you can see the table, what I was talking about. And I put over here technology on one side, and on top you can see the contamination, which you can find in water or wastewater on other streams. So technology should be dedicated to contamination, which we like to remove. However, there are some limitations, like always. So from my perspective, how I see the membrane, this is nothing else that this is the semi-permeable layer, which allow you to which divide the stream for 2 streams. One will be the purified, second will be concentrated. So in my case, we have also contamination. On this chart is showing ship, and we need to have drive force. In my case is pressure. So the valve will make the pressure on ships, so they will go through the semi-permeable layer. But some of them, they are bigger, so they will stay on the dirty part. And this is exactly how membranes is working, and also for tubular membranes is working the same. So we use pressure as a driving force for the movement of the filtration process. Of course, you can have concentration as a driving force or electric potential. So from my perspective, I would like to, because as a polymeric membranes, PCI is unique company which can produce not only microfiltration, ultrafiltration, but also can produce nanofiltration and reverse osmosis in polymeric geometry. So it's showing you that water will pass through all the kind of filtration processes. From the perspective of simple salt, it will be rejected by reverse osmosis. If we are talking bigger salts, divalent salts, then it will be nanofiltration. Micro cellulose, it will be ultrafiltration, and large particles, large suspended solids, microfiltration. So there is no limitation from the perspective of using type of membranes, but there are limitation of the osmotic pressure, because the driver here is, as I said, osmotic pressure. So we can run up to 80 bar on reverse osmosis. So that will be the limitation. So osmotic pressure, and other one would be viscosity of the fluid. So as far we know, we can remove on reverse osmosis, for example, 99% of sodium chlorides. We can remove the on nanofiltration magnesium sulfates or sugar or proteins. On ultrafiltration, larger molecules like active sludge, for example, and much bigger particles on microfiltration. So available geometries, we have at this point 4 types. The first one, which is the most usage in water purification and dairy, is spiral wound membranes. For MBR application, we have hollow fiber. Tubular is for niche applications. I will let you know where we are looking for. And flat sheet is more likely for MBR application, but they have some limitations too. So why tubular membranes? Why we are so proud of this product? So because we can run on high viscosity products, and also we can run on suspended solids because membranes will not block. They are resistant for blocking. They are robust and reliable and easy maintained. So we can clean with chemicals these membranes, or we can use special mechanical cleaning. It's required minimal pretreatment, so there is no requirement of prefiltration. It's limited only to protect the pump, to be honest. High quality product, as all membranes, there is providing the high quality product all the time. We can do the concentration step with one single process, so it's not required to have pretreatment and other steps. We can concentrate much higher on our membranes due to operation pressure, which we can allow to run on our modules. And we have experience of processes of applications. So basically, understanding the membrane. So let me show you how we are seeing the operation of our membranes. So on this table, you can see that you can find reverse osmosis, nanofiltration, and ultrafiltration, microfiltration. So for each type of membranes, we allow to run with applicable pressure. So for reverse osmosis, typical operation pressure is between 10 and 60 bar. For nanofiltration, from 10 to 30, and for ultrafiltration, from 2 to 25 bar. Pad flow, this is very important for tubular membranes, as you need to provide enough crossflow for the membranes. So it's from a reverse osmosis is 18 liters per minute. For nanofiltration is from 22 to 24 liters per minute, and for ultrafiltration and microfiltration is much higher. It's between 28 to 30 liters. The same with the flux. We can generate lower flux for reverse osmosis because it's tighter membranes. Slightly moderate flux for nanofiltration, which is between 20 and 80 lmh, and as ultrafiltration and microfiltration are much more open membranes, so we can generate much higher flow flux more than 200 lmh. We have different type of the membranes, A series, so I will leave the bottom description, but it's required enough to provide not only pressure, but also enough crossflow to have the turbulent flow inside the tubes. So over here, I will let you know what is important. Why when you start investigate a case with membranes, you should start with the right data. So you need to collect. If this is new application, or if you struggle with something, then it's worth to conduct some trials. So in my case, when we do the trials, we always try to focus on three major parts. The first one is do the pressure scan. So we would like to see how membranes will behave, how process will behave when we apply pressure. When is the breakpoint point? After that, we would like to do the process run. So is the batch mode? If this is batch plus top up, or continuous feed and bleed mode. So it is also showing you how membranes, what kind of achievement, what kind of concentration factor you can achieve, or separation. And after that, how we can clean the membranes. Can we clean the membranes? Can we make sure that they are resistant for fouling, and we can recover the process? There are 3 steps of collecting data are critical for us to find the suitable membranes for such application. So pressure scan. This is how we measure this. We apply. This is for reverse osmosis, for example. So we apply the measurement between change 5 bar after each 5 bar. So we are increasing pressure by 5 bar to measure what would be the flux production. So as you can see over here, around the 40 bar, there is no benefits anymore for generating flux by applying higher pressure. So it will be not economical to apply higher pressure because there will be no greater flux for this kind of fluid. Over here, we measure what will be the flux when we concentrate. So if you see there is 17 runs, and as you can see, if we generate much more data for trials, then we can see if there is some odd measurement or not, and we can much better predict what will be the most optimum operation for the membranes. As you can see over here, the major measurement is showing you that we can start from high 40 LMH and land at around 10 LMH with the 2.5 times concentration factor. So also showing you that of course we can go beyond 2.5 or 2 VCF. We can go with up to 3 VCF for this application, but the production of flux will be so low that the system will be 2 times bigger or 3 times bigger. It's not economical worth to have such system. So over here is showing you what will be the breakpoint for the design. So it's showing you on the below there is a chart when you have correlation between flux, VCF, and solid passage. So as you can see at 2.3 VCF, there is a breakpoint point. So there is a higher possibility to higher passage of salt. So the permeate will be dirtier, but the flux is going down. So from our design, we will go with the design 20 LMH with 2 VCF because it's the most suitable for this application. And as you can see on the table on the right, there is average retention. So it's beneficial for process to do not over concentrate because you have higher salt passage. And this is very important to see such measurement. The last but not least is cleaning. So we are not opening the membranes to clean to see if we can recover after cleaning. So we do the clean water flux test when we measure after cleaning what is the recovery of the flux. So when we install the new membranes, it's 100% for us. And we know that after the first run, you never achieve the same parameter as brand new membranes. So you can see over here that the flux is dropping by 10-20%. After this third run is over here that even dropped 31% lower from the original, but was not sufficient clean. So it's very important to understand how cleaning of the membranes is affecting your clean water flux. So how is affecting how membranes are cleanable or not. So this is the biggest problem, because if you cannot clean the membranes, or you have issues with your product, you have some fouling, if this is biofouling or from scaling, but the question will be, so we understand that, but the most important is what kind of conditions membranes are working. So everything is matter, because this is polymeric membrane. So if the cleaning regimes are really often and very with aggressive chemicals, so the lifetime will be shorter. The same with the process fluid. This is aggressive fluids, so it will reduce the lifetime of the membranes. Fouling the same, and process condition. If you run on the limit of the membranes, so it also will impact the lifetime of the membranes. So there is no answer clearly what kind of lifetime of the membranes will be. So because everything is matter, nevertheless we can always predict what will be the range of the lifetime for the membranes. So right now I gave you some overview how we are starting every single project. Right now I will let you know what kind of product we are offering. So you can see right now why it's so important for us to understand what kind of application we are working and what kind of product we can apply, because this is the range of our membranes. You can see on the bottom is the most open membrane, which is microfiltration 0.2 micron. But if you go to the top of the table, you can see that we can offer 450,000 Dalton membranes, 200,000 Daltons, 100,000 Daltons, and 25,000 Daltons, which without any supporting tubes. So up to 25,000 Daltons, these membranes can work up to 7 bar without any supporting tubes, because it will not explode due to the pressure. So if you go below 25,000 Daltons, then you need to apply special design of the modules, but also you can apply higher temperature. So we can work with polymeric membranes up to 80 degrees. We can see over here that we can go with 80 degrees for reverse osmosis. It will not harm the membranes, but of course this is maximum allowing temperature. With the pH, there is a type of membranes ESPO4, which is modified polyethyl sulfone, which can work from 1 to 14 pH. It's not a problem over here. So the range of the membranes is required for us to provide specific module design. So I will start with the simple modules, which is A series for us. And we have 4 types, which is A5, A19, A27, and A8, which is typical solid separation membranes. So we use this kind of membranes for fruit juice clarification, biomass separation, or concentration some products which based on suspended solids. They are very robust because they can run up to 60 degrees and 7 bar operation pressure. But basically, it's required higher cross flow to make sure that there is a turbulent flow inside the tubes. So the other range is our, let's call most popular product, which is B series. And over here, as you can see, it's stainless steel module with stainless steel tube nest, where we put every single membrane, which is 18 pieces inside the tubes. So we can apply higher pressure, we can run with higher temperature over here, and we can use any kind of membrane, starting from microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. So this kind of module allow us to do applications which they are unique. You will not block the membranes because the diameter of the tubes is 12.5 millimeter. And we are use this kind of membranes for applications which require higher pressure or better product quality. The series C, and it's very interesting series product because it's for water purification. We installed in this kind of membrane, this kind of module, 2 types of membranes. One is based on cellulose acetate material, which with cutoff 2000 Daltons. And other membranes, they are modified polyamide, which means nanofiltration membranes with 2000 also Daltons, but we allow us to run with different pH range. So the unique situation of these membranes is not only the tightest membranes which we are using over here, but the cleaning process also. So we apply over here two cleanings. The first one is mechanical cleaning, which is every 4 hours of operation. And chemical cleaning is limited only to once per quarter. This is for very nasty water, for very dirty water with high pathogens, with high colored water. So the foam balls are giving us unique chance to do not generate such much amount of wastewater for CIP processes. It's very common in Scotland, in Quebec area in Canada, Alaska. So it's suitable for rural area. Classic membranes, this is our latest acquisition product. It's cellulose acetate membranes, but in a reverse osmosis design. So we can run with higher concentration. There is plastic elements, so it's showing you that you can run up to 50 bar, 60 bar with plastic elements. In our case, it's stainless steel. Classic membranes give us a chance to offer polymeric membranes. You see over here only 7 tubes compared to 18, and also allow you to run with higher suspended solids application. We also offer for testing special modules, A5 micro modules, B1 with short version, which allow you to test any kind of application, to see the separation point of point, to see concentration factor, fluxes, etc. So testing is one of important part of developing the right application with the right membranes. And of course, this is the pilot plant feed, which is also in our part. The last but not least, as a PCI membranes, we are expert in membranes technology, so there is no barrier for us for geometries. So we do also spiral membranes and also hollow fiber for MBR applications. And now will be the case studies part, so you can see what exactly we are doing with our membranes. So this is the first application which is associated with EU for water and Procter & Gamble. So we are approaching over here the wash water handling. So typically approach for P&G plants was that that the wash water from the production line is what was waste. So unfortunately there was no technology. So only the technology available was biological plant with MBR application. So that was the approach, the mindset of such plant. In this case, you can see the wastewater plant. After that, you need to burn the waste. You need to burn the sludge. So that was typical approach. So high cost, how recycled cost. So there is no benefits of using such technology for small amount of wastewater with high COD load. So what we came through over here, so we say that, okay, you have wastewater from production line. What we can do, we can use membrane step as a one single step process to concentrate your product and to reuse your water. So you will not have, you will not get any wastewater generation. So basically, we split. This is the wash water, how it looks like. This is exactly the dishwasher fluid. And we use the membrane system to concentrate the wastewater. So we make the concentration of the product and generate the clean water in permeate. Of course, if you would like to reuse the product, you need to pasteurize, because you need to be 100% sure there is no any contamination from microbiological point of view. But you can, because this is soap-based material, you can reuse, you can use for external, for internal, or other application. And water, because it depends of what kind of concentration we are achieving. So it might be required some polishing to have water, for example, for reuse for steam, etc. So in this case, the win-win situation is that the plant, they didn't require any biological plant, but they went with one system in containerized design to concentrate the wastewater from production line. Is the other application over here, we as a PCI membranes, we can concentrate any kind of material, powder material from algae. So because we can offer tight membranes which allow you to retain all the important materials. So this is why with tight membranes you can reduce water content, but also you can keep the product on the concentrating stream. So we do this with below green algae, but also we did with the protein from any kind of vegetables like potato, like pea, etc. So this is something what applications, what membranes will. The right type of membranes will give you the right product, final product over here, without blocking the membranes. The other application is fertilizer over here. So we have seaweeds, which they are proceed by the fertilizer production, and over here was wastewater application. So if you see on the bottom, there is two glasses, and one is, this is after membranes. One is with the concentrated stream, and the second one with pure water. So the issue was with the plant that they generate a lot of BOD and fibers. So of course they need to build biological plant. In our case, what they find out that with one system they can reuse the membranes, is they reuse the product, and have water still for irrigation, for example. So in this case, we were able to concentrate up to 8 times with reverse osmosis membranes. The other application over here is about petrochemical wastewater plants. So usually with oily content, and of course you cannot use reverse osmosis over here, but you can do the combo system, which means you can combine ultrafiltration membranes in tubular geometry with polisher with spiral wound reverse osmosis. And so you remove the oily content. You will not block the membranes for reverse osmosis when they do the concentration. So it's possible to do the 2 stages. Economical, it's worth because the ultrafiltration, this is side stream membranes, so it's easy to maintain, and there is allowing you to run on oily wastewater. So originally, ultrafiltration is reducing the stream 20 times for this application. The other application is silica sol concentration. You can see on the bottom how looks like the silica sol. This is the material which is used typically on screening, on glass screens for cell phones, on coating, on paints, etc. So basically, on our system, we can concentrate up to 50 times, between 40 50 times of this product. So it's required high temperature and high suspended and high viscosity product. So this is unique offer from our end, and benefits over here that system give you the range of concentration. You can concentrate from 2 times up to 40 50 times of the product. So with one system it's possible. Other application over here is reuse brine water from olives and piri-piri paprika producer. So there was an application when wastewater containing some organics and COD, some salt, color and smell from paprika piri-piri. We use our nanofiltration membranes to reuse the simple salts, so sodium chloride. So all the contamination is on the retentate stream, but we allow only to pass through our membranes the sodium chloride. Of course, we need to make sure that there will be no biological growth, so we use UV lamps, and we were able to concentrate 4 times this stream. So beneficial of clients over here is that it's reducing the using of salt for the production process. Other application is over here. We have dried resins. So first step of this process was using the air to remove the large particles, but after that you need to wash all the grapes, dried grape resins. Otherwise, there will be still contain some sand. And in this case, we can concentrate such sugars, which can be used for the digestion plant, and to reuse the water for further flushing, raising of the resins. So it's over here, reverse osmosis plant, and this is not necessarily evil for the factory, but which is giving you one system to reuse the water for irrigation, for washing of resins. And that will be all from my end. Of course, I have much more applications, but I just want to make sure that this is very content is giving you some better overview how we start the application, how we measure the membranes, and what kind of case studies we are offering, because not all applications can be suitable for tubular membranes. But I believe that if you do the right starting screening process with the right type of membranes, you can see benefits of the whole process line. So that will be all from my end. Thank you.
Thank you, Piotr. Thank you for this very interesting presentation, very much oriented towards the applications. So this is something that we rarely see in our initiatives, in our events. So it's extremely interesting, and it's also nice to see what is the width of the applications that membranes have reached, and yeah, it's extremely useful, especially for young people, young researchers willing to pursue a career a professional career in the world of membranes, not only in academia. And okay, so I will, of course, I will be taking questions from the audience, from the chat on YouTube, but in the meantime, since we have a little delay, I am curious about one of the case studies you mentioned, and in particular, the one related to the purification of the wash water. And you mentioned that you need a further pasteurization of your stream. Is this required for legal purposes, or, I mean, it is actually contaminated? Okay.
No, it's not from legal point of view, but when you have membranes, you know, something can happen with the membrane, can break the membrane, something like that. So it's better to have the second step to make sure that there will be never contaminated. So there will be all bacteria will be killed. So this is why it's prevention instead of requirement.
Okay. Okay, I see. It's a kind of prevention, but can the pasteurization itself be replaced by a membrane process?
I don't think so.
Okay, not that you know.
So it's related to viscosity. So you cannot. It will be not economical efficiency if you have two membrane systems. The second system, it will not work properly.
Okay, so I'm waiting for questions from the audience. And what are the applications in the pharmaceutical field?
In pharmaceutical, so basically we are present with fibers. So any natural integrants like maltodextrin, this is what we can. It's high temperature. It's contain fibers, but basically we have such applications when we need to separate something. So maltodextrin is one of application. The other application is broth, which means any fermentation broth which separate, and you need to concentrate, and you need to behave very gently with the microorganism. This is also an application where we are present.
And another question is about failures. Did you have any application where membranes were not successful at all?
To be honest, of course, you can find such applications, but mainly it's related to failure of operators. So when you do this first part properly, which is the trials and pressure scan, and you can learn the application, then it should be not failure. So only operators make failure. I'm saying it's not as a guilty, but I'm saying that if they change something, or if the stream is different, or they forgot to clean the membranes, this is the main related failures. But from the application of the membranes, once installed, they are running. There is no issue. So we have such heritage application with their system operating for 30 years already in place, and they are still running. So we can concentrate yeast. We have such plant that there is yeast concentration. We can concentrate grape mass, which is wastewater for grape producers, but we can concentrate and get the product. So as I said, the failure, yes, they happen, but more related with some
the operation.
Change. Yes.
Okay, thank you. Okay, so there is a question from the audience, from Xueli. If your feed is characterized by high viscosity, which kind of membrane and membrane process will you use to concentrate it?
So it is high viscosity, so we are limited with pressure drop. So it will be required to have ultrafiltration membranes with parallel end caps. So it will be required higher cross flow to make sure that will happen, but limited. Of course, you can use other type of membranes, but there will be no high product quality, so you will not get higher concentration. So if this is high viscosity, because I don't know what is the product, of course, and what will be the outcome, but I will start with ultrafiltration, any kind of ultrafiltration, very tight or open, how membranes behave. But definitely, high viscosity fluid is not helping.
Yeah.
Because in our case, the limitation is pressure drop. So yeah. It's module. Now, if this is more than 9 bar on module, it's not beneficial. It will be not the right application.
Okay. Let's see if there is any other question.
So I can add only over here that any juice what we are drinking from concentrate, when it's juice from concentrate, they need to be clarified on membranes. So they are really major of plants globally who's producing concentrate, juice concentrate. They are using tubular membranes, and many of them using PCI membranes. So we are very proud that when you see the juice from concentrate, you're very likely drinking juice from after our membranes, because you need to remove all the pulp. Otherwise, the evaporator will not work properly. So the fibers and pulp need to be removed on the membrane stream.
So this is a pre-treatment before the evaporation stage.
Yes, okay. There is. Yes, the pasteurizer and evaporator. Yes.
Okay.
But mainly, of course, you can drink the cloudy juice, but you cannot make the concentrate from cloudy juice. So this is why when it's cloudy juice, it's always fresh juice, fresh squeezed juice. But from concentrate, it's always or use evaporator.
Okay. So I see no other question.
If there be any questions further?
Yeah, I mean, I have a curiosity. Was there any impact of the COVID emergency on your activities, or did you have any special COVID-related question from your customers?
Yeah, related with COVID, as PCI, we are more focused on applications than wastewater. So wastewater is one of our part, which will grow, of course, but we focus on more on food and beverages, dye applications, which is you clarify the juices, water treatment. So from our perspective, we see higher demand of new products development. This is what we see. Like right now, there is a big boom of be innovation, be good with the first product. So we are taking part of graphene development. So on our membranes, there is a graphene production. We see also on our membranes some application with protein separation. Also, on our membranes stevia clarification concentration. So this is what we see right now from the COVID. From perspective of our customers, we see right now that there's more issue with the supply chain because there is long lead time. So everyone is in panic and buying more and more for stock instead of stopping the production. So it's more predict their business. They want to protect their business with buying membranes on stock or systems. But yeah, for sure.
Yes, I thought about something more that
this issue is troubling.
More directly related to the virus itself, or whether it is possible to remove the virus with a membrane. I mean, someone could ask that.
From my perspective as a PCI, we cannot do anything, but we have sister companies calling Porex, P-O-R-X. So they make the testing for COVID. They make the filters for testing. So Porex company, I recommend. They are very innovation company, and they do other stuff than PCI, because we as a PCI we focus only on water and wastewater and food, which is only fluid-based application related to COVID.
Okay, I have a question from the online audience, from Lydia Giorno, and she's asking, which is the flux value that you may consider acceptable from an economic point of view? For example, in the water treatment.
This is a very good question. So we will do the screening for sure. We will see the pressure scan. After that, we will see what is the solid passage. So we will see how much we can concentrate and what will be the outcome from the system. Because what we are doing, we are concentrating. So for our aim is to concentrate as much as possible as we can, and the permeate is let's call it waste for us. So we don't care about. Sometimes the customers say to us that you need to also keep the permeate clean. So the flux, it will be not fixed value. It will be related to the concentration. How far we can concentrate to keep the permeate clean. So for such application with high viscous fluid, high temperature, I would say it's 10 plus LMH. So this is reverse osmosis, of course. So 10 LMH and higher. That would be the economical table. Everything below 10 LMH, I don't think so. There is a driver.
Okay.
Because it will be too bigger system. Because of course the concentration, the flux will change during the concentration stage. So at the beginning it's higher flux and will drop down. So we always need to consider that. So of course you can run further when you deliver the system, but this is your decision. But for the design, we take the most economical part.
I see. Okay, let's see. If there is any other question? There is always a little bit of delay with this system that we use. Okay, she thanks you. And so the question was answered. Okay. Is there anything else you would like to add? Otherwise, I will end the session.
Yes, I would like to add one sentence. It's very important to know what kind of membranes, what kind of geometries are suitable for application, because I will never offer tubular membranes for simple seawater or brackish water desalination. It's not the point. Of course you can do this, but there is not a real driver. So membranes can do the job, but if there is it's light application, there is no suspended solid, tubular membranes will be not the best one. So they are suitable, but only for some conditions like high viscosity, high suspended solids, very nasty water, very difficult for other membranes, because other membranes can fail, but tubular membrane can do the job. So this is only my advice. Don't push the type of the membrane.
Yeah. Don't push the.
Which it will be too easy for such a.
Yes.
It's not worth it.
Thank you for this advice, and thank you for this interesting talk. This will be, of course, uploaded on YouTube so that people can watch it. And okay, thanks to Marcus Stoller, and thank again Piotr BRUZDA for his presentation. And I thank you, of course, to the audience. And let's see each other in the next webinar next month. Okay, thank you very much.
Thank you very much for the invitation.
Bye bye.
Thank you. Goodbye. Have a nice afternoon. Bye bye.